This is lesson 10-6, which is outliers. Outliers are kind of fun and interesting. So here we go. An outlier is a data value that is very far away from the other data values. It can be much greater in value or much less than the other values. So here's a data set. Let's consider this data set. How do you know if either of the extreme values, 225 or 780, are considered outliers? So here's our data. They already ranked it from least to greatest for us, and you can kind of see that we've got our extreme 225 over here on the low side and our high extreme or maximum of 780. How can we tell if these are considered outliers or not? An outlier is defined as a value that lies more than 1.5 times the inner quartile range, either above Q3 or below Q1. So in order to do this, we're going to need to do some median work and some quartile work and all that to see if these extremes are considered outliers. So to find the IQR, you should remember this, we need to find the first quartile, median, and third quartile. Since they already listed these in order for us, we can just take their word for it. And our median, they have said, is 387.5. That's halfway in between 387 and 388. Our Q1 is 300 over here. They had to go 295 plus 305 divided by 2 for that. And our Q3 is 475. Again, they would have had to go 470 plus 480 divided by 2 to get that 475. Okay, so now we have those. And we can continue on to find our IQR, which is Q3 minus Q1, or 475 minus 300, which is equal to 175. Then we're going to determine if these are outliers. So remember, our upper limit of the to determine if it's an outlier or not is Q3 plus 1.5 times the IQR. So remember, our IQR in this case is 175 and our Q3 was 475. So we're going to put this into our little equation here. We've got 475 plus, in parentheses, 1.5 times 175. They're simplifying the parentheses down to 262.5, and then we're adding that to 475 to get 737.5. So you just have to remember this 1.5 times IQR thing, and then you add it to the quartile. And then on the bottom side, you do the same thing, only instead we're subtracting because we want to know if it's like too low. So you still simplify the parentheses. We've got our IQR here. Our parentheses simplify down to the same thing, but this time we're subtracting 300, which was our Q1, minus 262.5. So we've got on the upper side, we've got 737.5, and on the lower side, we've got 37.5. So if our numbers in the data set on the upper side, if they're higher than this, they're outliers. If they're lower than this on the left side, on the Q1 side, then they are outliers. So any data values that are greater than 737.5 or less than 37.5 are outliers. So the value 780 is considered an outlier. It's higher than 737. Because the data set does not contain any values that are less than 225, the only outlier is 780. Everything else is within these limits here. All right. Okay. Example 1, identify outliers. So let's do that again and just make sure we've got that in our brains. What are some real-world problems involving outliers? Watch the animation to find out. Let's start there, actually.
In an upcoming election, there are 7 candidates running for an open seat in the local city council. The candidates' ages vary from 23 to 72 years of age. Are any of these values outliers to the data set?
Okay, that's just like a when it might matter. So here we go. Let's find out. Step 1, find the quartiles and interquartile range. We already know how to do this, but we still got to do it. Okay, so let's put these in order from least to greatest, because they didn't do it for us this time. Okay, and then, yay! We're going to determine the upper and lower limits for the outliers. So they already skipped a step for you here. They found the median of the data, they found the Q1 of the data, they found the Q3 of the data, and then we found the IQR by subtracting those. So we've got our IQR, which we need for our formula here, and we've got our Q1 and 3, which we also need. So the upper limit is Q3 plus, and then in parentheses, 1.5 times the IQR equals something, okay? And so we know our IQR is 15, they put that over here, and we know our Q3 is 63. So we can go 63 for our Q3, and then we can multiply 1.5 times 15, and that's going to give us 22.5. And then we can add that to get our final upper limit of 85.5. Okay. And then we can do it again for the lower limit. This time our Q1 is 48. And so we can go 48 minus, this stays the same because our IQR does not change here. So we can go 48 minus 1.5 times 15, or 48 minus 22.5, which is 25.5. So that's our lower limit. And then we can compare those limits to our original data. So are there any ages less than 25.5? Well, yes, there happens to be 23. Then click, please. Okay, thank you. Which age? 23. Are there any ages greater than 85.5 years? No, the highest one is 72. So that means the only outlier in this data is 23. What does it mean that 23 is an outlier? Well, that just means that it is kind of an anomaly, or like maybe an exception, or some kind of data piece that doesn't really coincide with the rest of the data pieces. Something like that. All right, so you try this check. Don't forget, when you're finding your median, you need to list the values in order from least to greatest so that you can find the medians, and then the quartiles, and then the IQR, and then you can go from there using your formula. All right, let's look at the next thing. Describe the effect of outliers. Outliers do affect our data when we are trying to calculate things or analyze things. And so it's important to know when they're there. And sometimes we remove them from the data. Sometimes we just consider them when we are presenting the data. It just depends. So if a data set contains an outlier, the outlier may affect the measures of center and or variation. Suppose you track the daily high temperatures for 1 week. The results are recorded in A. In A? Okay, in a table, I think that's supposed to say. Okay, so here's the table. So on Saturday, the high temperature is 42. This temperature is much lower than the other temperatures in the data set. It's also an outlier because 42 is less than the lower limit for outliers. So they did this calculation and they found that 42 Saturday, which is not shown in the table, it's just told here, 42 would not be considered part of the normal data set. It is an outlier based on their calculations. In case you need to see the IQR, here's that. That's on your page as well. To see how an outlier affects the measure of center and variation, calculate the values both with and without the outlier as a data value. So if they use that data from the previous table and you kept the Saturday in there, the mean is 67.7, and then the mean absolute deviation is 7.4, the median is 72, and the IQR is 6. If you take that outlier out, see how it changes our mean? It makes our mean go higher because that value was low. It was a low outlier. It also drastically changes our mean absolute deviation because the distances between the data points and the mean is what this is, the average of that. If we have an outlier, it's very far away from the mean. Like that was a very low end number that was not fitting with the rest of the chart. So by taking that out, that's going to mean that our mean absolute deviation comes a lot closer to the mean, and so that number is much smaller. The median happened to not be affected because it just added one more value, and the median is not necessarily about the values of the numbers themselves, it's just about which one falls in the middle. So that one wasn't really affected. The IQR was affected quite a lot here as well. So it went down without the outlier because that outlier was on the lower extreme on the left side, and would have shifted our box over, like made it go a little smaller. It just it would have affected our quartile values and things like that. So that is quite a big change from just one outlier. So that's why it's important to identify them because it does affect your data, your analysis. So you can use either the mean or the median when the data does not contain any outliers, but when there is an outlier, you should only use the median. The median might change a little bit when an outlier is included or removed. It does not change as much as the mean most of the time. There are some exceptions to that. Then you can choose the corresponding measure of variation to describe the spread of the data. So if you choose to use the mean, because there's no outliers, then you could use the mean absolute deviation to describe the variation. If you do choose to use the median to describe the center, then you want to use the IQR to describe the variation. So mean, MAD, median, IQR. You want to make sure you do that. And then outlier, median. If you have an outlier, you should use the median. All right, describe the effect of outliers. Example 2. We've got a turtle, or I guess that's a tortoise. Okay. Calculate the mean and median with and without the outlier 200. Then choose the measure that best describes the center. Okay, so in this case, they're already telling us the tortoise is an outlier. We don't have to calculate all of that out. Sometimes you will, but this case, you can kind of just tell. Look at all these numbers, and then all of a sudden 200 is in there. So we're going to calculate the mean and median both with and without it. So we've got our numbers here. They're going to find the mean for you. Notice they're using squiggly lines for approximately. That's because we're going to do some rounding here. So we're going to just round, we're going to round it to 62.1. The mean lifespan of the animals is approximately 62.1 years. You get that by adding and dividing by 7, by the way. And then the median, if you order these from least to greatest, you can find the median. So that would be 20, 30, 30, 35, 50, 70, and 200. So 20, 30, 30, so a 35 is going to be our median, I think. I did that in my head. You guys, you should put this in order from least to greatest if you're unable to do it like that. Okay. So then if we take out that 200, we can see that our mean changes to 39.2 years about, because we're rounding, that's why we're using about. And this time our median is going to be, we've got 20, 30, 30, 35, and then we've got 70, 50, 35, 30. So we're going to have in between 30 and 35, which will be 32, I think 32.5. Is that right? I'm not crazy. Awesome. Okay, so then we can compare these two situations. So without the outlier, we have a much, much lower mean here and a slightly lower median. It's way less dramatic than, like, this is kind of like half almost. So the mean was most affected by the inclusion of the outlier. The median changed very little. So in this case, the median is going to describe the data better, regardless of if you take the outlier out or not. Why would it make sense that the lifespan of animals listed in the table are centered around 32.5 or 35 years rather than around 39 or 62 years? Well, if you go back and look at the table, you're going to see that more data. We've got a 30, a 35, another 30, a 20. It makes more sense for it to be in this range, whereas you only have 150 and 170, and then one crazy number, that 200 is what's bringing this up. So, like, other than the tortoise, only one lifespan in our table is higher than this 62 years. The rest are under that. So it makes more sense for us to use these values here. All right, you try it. The end.